Yes. Sometimes we need to scan our images. I mean the Docker images. Okay, be- before deploying to production, because so many vulnerabilities are inside the Docker images, right? So we are using try for uh, I mean scanning the vulnerabilities. If any vulnerabilities are in any Docker image or anything. So I am preparing one end-to-end CI/CD, include all the end-to-end CI/CD. Okay, include DevSecOps. I mean the some security aspects. I include some security aspects in the CI/CD pipeline. Okay, so today I will take a section regarding observability. Okay. Do you all heard about observability, right? Observability. Anyone?
No, sir.
Anyone heard observability?
No idea, sir.
What about others? Okay. What about monitoring? Monitoring?
Yes, sir. We've heard to monitor.
Okay. Okay. Uh, okay. For example, we have different Kubernetes clusters. Okay. So we deployed some application. I mean some client application inside the Kubernetes cluster, and we write up the service, and if the application is front end or back end, as per the requirement, we need to expose the application and all the thing, right? Basically, we are deploying our application inside. I mean, uh, yeah, as per the hierarchy, we deploy application inside a pod, and the pod belongs to node like that, right? And the cluster have at least two node or above two nodes. As per the requirement, or is if the requirement is big, we need to deploy more nodes. I mean, in a Kubernetes cluster, we need to deploy more node, like 5 node, 10 node, 50 node, like that. So our job is to deploy the application, and after that, okay, our application is all done. We deployed, all the thing is done, and everything is fine. But we couldn't say everything is fine because we need to monitor these clusters, right? Am I right? For example, this is our cluster. Okay. So inside the cluster, there is two part, right? Master and worker part. So here, consider there is 6 nodes. 6 virtual computers are there inside node we deployed different pod, okay. For each pod, there is a container that has to run a specific application, okay. Okay, so we set up the thing. I mean, everything is done. Configured, all the thing is done. EKS, consider this is the EKS cluster. Okay, so in real world scenario, we need to, we are not the one who monitor this part. For example, if the company is big, then there is a monitoring team there. So we just share the credential or getting onboarding. I mean, some users are there. I mean, for monitoring. So we just onboard the users for monitoring purposes. So yes, yeah, set up the things. Then we need to monitoring this part or under the observability, we need to set up something inside the cluster, right? For the monitoring purpose. Plus monitoring. So we are using nowadays some open source telemetric tools or yeah, user interface tools for monitoring. Got it. How the monitoring works, we deploy some application inside the Kubernetes cluster. Okay. First we install some application, source open source application, apps, and we can monitoring our cluster using these open source application. And anyone know what are the open source applications nowadays available for getting the logs, metrics, and yeah, all the things, and for the user interface? All of you. No one know?
What about Prometheus and the Grafana?
Yes. Right. Right copy.
I think
Yes. That name is Prometheus. And Grafana. These are the two tools we are using nowadays because both are open source. Then we configure, I mean, we deploy these application and we leverage the application maximum. I mean, as per the requirement, we need to configure or customize some things we can do. So, what is Prometheus and what is Grafana? So, Prometheus is an application, okay? It's an application. These are two applications, okay? It's an application will do some jobs for Grafana or any monitoring tool, okay? Here the monitoring, entirely monitoring part is Grafana, okay? We get a dashboard when we deploy or configure Grafana, we will get a user interface. So there's a user interface. This is a user interface, okay? Consider for Grafana. So Grafana needs some metrics, logs. Grafana needs metrics, logs, traces, and related thing, okay? So who will give these details? That's where the Prometheus works, okay? Prometheus is the one who will send metrics, logs, traces, all related data from our cluster, okay? Even the cluster application, node details, cluster details, application details, even our cluster, Kubernetes cluster full details, the Prometheus will send it to our Grafana. Got it? Even how many deployment we have done in our cluster status, cluster node status, CPU status, then how many nodes are there, how many ports are there, how many applications there, which application utilize the memories use CPU utilization, memory utilization, network utilization, all thing we can monitoring with these two tools. Got it? Anyone have any doubt? No doubt, right?
Yeah, I have a question.
Yep.
So we need to install both Prometheus and Grafana, right?
Yes.
And what is, why we use Kibana?
We are not using Kibana because for Kubernetes cluster, we are mostly go with the Prometheus and Grafana. Kibana, when some other scenario, we need to set up with the ELK, okay? Elasticsearch, Logstash, and Kibana. We integrate these three things. Elasticsearch is a Linux distro, for getting the logs from our Linux machines. Then we use Logstash. That's under the ELK, okay?
Yeah.
ELK,
Okay.
yeah.
Okay, thank you.
Any other doubt? Cool, right?
So are we installing this Grafana and Prometheus in every node or in a cluster where we are, do we need to deploy in every mission?
If we deploy every machine, it's a messy thing, right? Not we are not going the a single machine. In coming to Kubernetes, we just deploy inside a cluster. So the worker part will automatically deploy. Scheduling our deployment to different nodes. So we didn't bother about anything. For example, this is a cluster scenario. Okay, coming to a single virtual machine, we just deploy the thing in a single machine. Assuming that there is a EC2 machine like that. For example, here multiple nodes, right? Node 1, node 2, node 3, node 4, node 5, node 6. Assume that we deploy a single application, not the Prometheus or Grafana. We have one application like ABC application. So we create the file, deployment file, and send that to the master part. To the API, right? Kubernetes API. So that single ABC application will deploy any of the machine. The available machine. The scheduler will scheduling and send it to the best machine. It will, if the deployment is, the replicas is 10, for consider the replicas is 10, okay. So it will share the application to all the nodes, for example, some scenarios. So our, in real scenario, our applications, this first node, second node, third node, all nodes have our application. The replicas of our application. If any node is down, our application is another node like that. That's called the maximum availability. High availability of our application. The Kubernetes cluster will handle the high availability. Got it?
Yeah. Okay. Thank you.
If yeah, I think I lost my previous account, so I need to install a Kubernetes cluster. Then we can start the lab, right? Everyone.
Yes, sir.
Okay. Everyone done the CI/CD part, right? The basic. I hope everyone done because coming section or yeah, or Friday or coming. Today is Wednesday, right? Oh,
Monday.
sorry, Monday. Yep. Yeah. This week I will set up the thing. I mean the end-to-end CI/CD. So through the declare, I mean for the basics pipeline, we are going with the pipeline, right? I mean not pipeline. Which one is demo, right? From scratch, creating from scratch. So coming, I mean real world pipeline, we are with the declarative mode. Okay, we write up the codes and create the pipeline. Now I installed the previous things like Kubernetes and EKS for deploying the application. That's all. And I need to go to IAM. Create a service account to authenticate. And one more thing we need to learn in this lab that is called Helm. Anyone heard about Helm? Helm. Anyone?
Yes,
Paycheck.
Kubernetes
Yes.
What is the use of Helm? And what is Helm?
package manager.
Okay. And the use of package manager?
I think we need to deploy more package at once in a Kubernetes cluster.
What is the benefit if we are using Helm package manager?
Maybe it helps us to upgrade.
Separate?
No, upgrade, install these kind of charts. It can help us.
Yeah, you mean from community, right? For the latest deployment.
Yes, yes.
Yes. For others, I will explain what is Helm. Helm is a package manager, okay? package is a package manager. So what? So Helm have so many packages, right? So Helm have packages. And what is packages? It's nothing, okay? For example, we have a Kubernetes cluster and we need to deploy a application, okay? For that, what are the prerequisites? We need to write a deployment YAML, right? For deploying an application, we need to create a deployment.yaml, right? Then there is another application, some open source applications. So consider coming to production environment, we need to handle different, lot of YAML files. Okay, it's a messy thing when coming to it's if the application is open source, it's a messy thing because we keep the same application YAML file. So many YAML file for different open source application, not our company's application. For example, a MongoDB deployment YAML file, a Nginx deployment YAML file, or like that, like Kubernetes or Prometheus or Grafana deployment YAML file. So we didn't save, the open source deployment YAML file. Okay. So what will you do? We can copy the package. The Helm where in Helm package manager, these all the deployment YAMLs are there. We just add the Helm, install Helm in our machine, and using the Helm package manager, we can directly deploy application. We didn't bother about the YAML file. That's one of the main thing. Got it. And we can deploy latest community file. Community deployments. So many things we can done with the Helm. One of the main thing we are using Helm is we didn't bother about the deployment part, just deploying. That's all. In our case, I will show you how to deploy Prometheus and Grafana using Helm. Okay. Got it.
Helm and Ansible, they work the same way.
No. Oh, Ansible, we are creating Ansible playbooks, right? And inside the playbooks, there is so
Yes.
many details, and we push the code to the corresponding provider.
But
Ansible is an
Helm
automation.
also just okay.
Yeah.
I learned that Helm also is like a chart with the YAML file. So
Sorry.
out of the chart.
I couldn't get you.
I'm saying that it's because when I learned that Helm uses using a
Your voice
template
is
called chart.
breaking. Voice is breaking. I know. These are the old parts, okay? That's why I didn't explain. What happened?
select the instance.
Sorry. Yep.
Yeah.
Yeah, now I created a service connection. Okay. So next part is trying to install the cluster, right?
My node, one word.
Sorry. Your voice is breaking. This is a coffee, right? Can you test it to me? I mean, the chat. I'll be back. Okay, 2 minutes. Yeah, I'm here. Okay. Anyone have any doubt? We can discuss. Okay, because in case will take little time to deploy.
So these Prometheus can be used with the other type of cluster deployment also. Like this is EKS. We
Yes,
have different
it's
types
open
of.
source. Open source. For example, this is EKS. Okay. Then the next service is AKS. Then GKE. then we can deploy directly taking some machines and deploy Kubernetes cluster. For example, for master part, we need to configure one machine. For worker part, we need to configure different machine, and we can create a cluster in between these machines. Okay. For the providers manage EKS, I mean EKS or AKS, EKE, we didn't bother about this because everything will handle the provider. That's why we are directly deploying EKS using these services. That means EKS or AKS like GKE. So after setting the cluster, we will get the Kubernetes cluster actually, right? Inside these services, we will get Kubernetes cluster. That's why we are using kubectl, get node kubectl. All we are doing with the kubectl. So that then we can deploy the same things in every environment because all are same. Got it?
Yeah, but EKS has, because it is an AWS service, so
Yeah.
we can configure CloudWatch now. Why should we take Prometheus?
Sorry?
We can use CloudWatch, right? It is already there in the AWS. So why we are choosing Prometheus?
Yes. For CloudWatch, it's how can we say? We need to configure the CloudWatch and getting the old things to the CloudWatch, and then CloudWatch is, it will take charge, right? It's not a free service. Then, then the user interface also, you see the user interface of CloudWatch, right?
Yeah.
So many things under the CloudWatch. I mean, so many, like when comparing to Kubernetes, the Prometheus and Grafana, the CloudWatch is a small thing in comparing.
Okay.
Yeah.
Mhm.
This is entirely observability part. This Grafana and Prometheus and Grafana. And coming to, when comparing CloudWatch and like our Grafana or Datadog, any applications, coming to CloudWatch, there is less observabilities, I think, like the percentage. So many things there. But this is entirely for the Kubernetes cluster. So we will get all of the data from the cluster. The deployments. When we configuring, you can see the how the data we can getting from our Kubernetes cluster from the monitoring part. And I don't believe in CloudWatch all the things we can watch in the CloudWatch.
Okay. So there is another type, is there, no? COPS? KOPS.
Yeah, COPS.
Yeah.
COPS for deploying the Kubernetes, right?
Yeah. Are we, like
COPS
in the
and
real
Kubernetes.
time still they are using?
Sorry?
In the real time, still they are using KOPS type of Kubernetes cluster?
That's all after the requirement. For the company requirement, we need to go with their own requirement. COPS or KubeADM.
Yeah.
Yeah.
Okay. Thank you.
Yep. What about all of you speed up of our classes, for example? If I believe we are on track, right? So we can speed up. taking more classes in the weekdays. If everything is done, I mean, everyone is okay, then we can do the same. So we can clear all the things. I mean, the other parts of the training, all things we can do faster if we complete the training part faster. Okay, G. Then we can go with the same, I mean. Okay, okay. Got it. Okay, fine. My cluster's ready. Okay. So now we need to install one more thing that's called Helm. Okay. Coming to Helm. We are installing Helm from the GitHub. Okay, go back. I'm curling the Helm script, okay, for the get Helm. Give the permission for get Helm.sh.
So curl dash FSSL. Can you please explain that?
Sorry.
SL. Can you just this command? I don't understand. SSL.
Yes.
What?
Your voice is breaking.
Can you hear me?
Yeah, now it's okay.
Dash FSSL curl
You mean the first command,
that
right?
command that
Yeah, that's for the curling command. Why we use curl command?
you this one it comes with SSL.
Your voice is breaking again. What about others? Same, right?
Yes, sir, it's breaking. So can you please put your question in the chat?
So do we
So
need
he's
to
asking what is -fssl after the curl command.
Okay, got it. That's for first we use curl command. Okay, curl means to getting the package from this directory. HTTPS. I mean, where the application belongs. We just copy. We can see the thing. You see, this is the package we need to we need, okay, for installing the application. Then we commit to FSSS. Hyphen FSSS means the F in this FSSL, F means it's indicate the fail, okay. I mean, if any error happening, we will get the error. For example, this URL is not done or anything like that. I will explain.
Small f means it fails without any silently no output in the fail.
Yes. And coming to yes, it's a option called it's indicate a silent, okay, like makes our curl command is in silent mode. We will get a silent notification. Like for example, sometimes we need to prevent some progress meters or some error message from this this display. Then the big S, you see, this is for the smallest. and the biggest, that's also like showing the error, like tells curls to show error message if any error occurs. Then it used to like a conjunction, okay, with the smallest. It suppresses the progress. That's all. For the biggest. And coming to the big L, it's the location actually. I mean, to tells to the curl. All the FSSL tells to the curl. Okay. I mean, each one have their own responsibilities for setting the things. I mean, the first step for fail, the second step as smallest for the silent, and the third for showing the error. The fourth L for the location. I mean, location means to follow the HTTP redirect, and so many things happen in the big L. Then the O, this O, okay. This option is followed by the same curl command, okay. I mean, it will save the data. I mean, download data. This is the data. I mean, we explained the HTTPS. This is the data, and we are downloading this data actually. Got it?
You explained already. Thank you. The FSA. Thank you so much.
So do we need to install Git for this
No.
installation? Because
We
it
didn't.
is
No.
saying
No, we
did
just
not.
curling. That's all. Not using.
And below there is a warning, right? So that's why I'm asking.
Where?
There is a under sudo /get _helm.sh. Under that is warning.
Yeah, we are just entering this here. Okay, I mean opening the get. This is a script. Okay, where the package. I
Yeah,
mean,
but there is a yeah.
just
Because
open.
it is saying could not find Git, right?
And no problem, because you know, we got the client version here.
Yeah, that's what I'm looking at.
Yeah.
Thank you.
Okay. Our requirement is just installing the Helm client package. That's all. Yeah. Now it's all done. We configure our machine and install EKS. Now we have a EKS cluster. kubectl. Yeah, there is 2 node that's running. Okay. Now I have one configuration part. Now we need to add some charts. Okay, I mean from the Helm, using Helm, we need to add the Helm stable charts. Okay. Now we are using Helm commands. That's why we are using Helm. First command is Helm. Okay, so the Helm stone, that is for the Helm commands. This is Helm repo add stable. Okay, this when we entering this command, the Helms know there is a stable repository for charts.helms.stable under the stables. Okay, so you see stable has been added to a repository. Now we are going with our required thing. Okay, our requirement is here Helm repo add Prometheus community. We need to add the Prometheus community, and we need to provide the Prometheus community URL http Prometheus community github.io Helm chat. So it will shows all the community Helm charts. Yeah, we added the Helm community in our machine. Then we need to search. Okay, search for Prometheus, because in the same community there is so many packages are there. So we just searching our Prometheus community. Inside Prometheus community, these are the packages. Okay, this you can see the packages around 20 or 50 packages are here, and each packages have its own configuration, different configuration. This for Prometheus community for alert manager, and the second one is for Prometheus community, and it's for alert manager plus SNMB, then notifier, then Jira alert, Cube, Prometheus tag, Cube status metrics. These all are basically these all are the YAML files. Okay, for the different configurations that related with the Prometheus. That's all. And all are community version. Okay, that's why it's say community. So we can say these are the updated one. So in our case, we are going with the Prometheus stack. Okay, Cube Prometheus stack or Cube Prometheus stack. We are going with Cube Prometheus stack. Before that, we need to create a namespace. Okay, for Prometheus. We didn't install the package. Okay, I mean this is our package. Before that, I'm just create a namespace. Under the namespace, I deploy the package. I mean the above package. Now I created a namespace. Prometheus is there. Under Prometheus, nothing, I think. kubectl get all namespace Prometheus. No resource found in the Prometheus namespace. Now I install the package. I'm talking with the Helm. Okay, Helm, please install this package to this Kubernetes namespace. Helm install stable Prometheus community cube stack. I mean this pack. There it is. Yes, Prometheus community cube Prometheus stack. Got it. And to this namespace. There is a namespace for my Kubernetes cluster. This is a namespace. Hit enter. I think my machine is not responding. Stop mission.
You see, when we stopping the machine, the IP will change, okay, the public IP. Okay, it's fine. Now you see, under the deployment, I mean, Prometheus using a stack, I mean, using a Helm chart, that these are the deployment, okay? The pod manager, pod stable queue, Prometheus, stable Grafana, and so many pods are there, okay? You see, then the services. Under the deployment, we got services related to Prometheus Operand, alert manager, then daemon sets. This much pod we created, okay, using the Helm chart. So we need some pod, okay, I mean to expose some application for getting the Grafana UI. So everything is fine. Okay, Prometheus. Okay. This is for getting the service, okay. That's with the Prometheus deployment. So these are the services, okay. So services for different process. I mean for the internal process. That's why all of us some cluster IP. Cluster IP for the internal communication. So here, this we need to expose. I mean the Prometheus, stable Grafana. That's why we will get the user interface for the Grafana, and the Prometheus will send the logs and metrics to the corresponding Grafana. So quickly we need to now I am going to edit the service. Okay, there is a service YAML. I will show you the service YAML. Yeah. Who wrote up the things? I mean the YAML. This is offered by Helm chart, right? So that's I told you we didn't bother about. We didn't bother about the YAML file. Again, it's stuck, I think. Can't scroll down actually. Because we need to edit the type actually. Here the type is here type is cluster IP, you see, and we didn't have any external IP. So we need to write up the external IP with the load balancer. That's I'm trying, but I couldn't go there. Okay, I think, yep, now it's done. Okay, fine. You see the type, this type is cluster IP, right? So we need to change to load balancer. This is a way how we expose our application, okay? Load balancer, load is, L is capital and B is capital. Otherwise, we will get some error. Escape, rewrite WQ. Hit enter. Yeah. Now it's done, okay? So I will check again. You see, now we will get a ARN. That's for exposing our application to load balancer. So the next thing is edit Grafana. Same for the Grafana. Copy. Go to the type. Change it to load balancer. And you see, it's the package. Kubernetes know that there's a Grafana and it's edited, right? Okay, again, we need to check to the Prometheus services. Now got it. One for Grafana. We got the Grafana UI. Copy the URL and paste it here. Okay, paste it enter. It will take some time because we need to configure the load balancer and routing. So many things happen in the backend. Yes, it's done. Okay.
Yep. This is our Grafana UI, where we monitoring our application, I mean, Kubernetes cluster, Kubernetes deployment, pods, node, our application, all things we can monitor here, okay? The admin is admin, user means, this is a default username. Admin and password is from operator, I think. Yeah, the password is from operator. Login. And this is our dashboard, Grafana dashboard. You can see this is our user profile. We need to add as per the requirement or company purpose. Then this is our home. Here the basic details, I mean, how to getting the source, how to create the dashboard. Okay. And most probably, I mean, dashboard creation or alert configuration, all things done by the SR guys, okay? I mean, site reliability engineers there. They will handle the configuration, I mean, the metrics configuration part. We are just deploying, some cases we just deploy this application. Some cases we are the one who need to configure, I mean, onboarding our application. As of now, we didn't onboard anything in here, okay? That's why it's like this. We need to onboard our Kubernetes cluster in here, okay? How we onboard, I mean, how we import the data from our Kubernetes cluster, our Kubernetes cluster. So just to go to add, you see your add option there, and there is new dashboard, import dashboard, so many things there. We are now going to import dashboard, okay? So here we need, here some numeric thing, I mean, for it's customized some types of dashboard, okay, like 6413 is for some type of dashboard of Kubernetes cluster. Then some other numbers denote some other configuration part. Configuration means we getting some details, okay. For example, this metrics like 6417 is only showing the application status of a Kubernetes cluster. Like that, we need to onboard entire Kubernetes clusters, and we use different numbers for importing to Grafana, okay. Then load. Our data source in our case, our data source is what? Prometheus, right? Because Prometheus will send the data as metrics, logs, traces to our dashboard, okay. I mean, Grafana dashboard. So here we need to choose the Prometheus. Please. Yeah. Fine. Then directly we can import, I think. Okay. Yes, now it's all. And now I am on board dashboard with a, yeah, it's automatically fetch the name, okay. That is Kubernetes monitoring dashboard folder, and we need to choose the source, okay, drop down, and Prometheus default is our source, and just import. Done. Our part is done. Now we will get the dashboard of our Kubernetes cluster.
Now it's fetching data from Kubernetes cluster. You see, now all are onboarded. Yeah, cluster memory usage, CPU, cluster CPU usage, cluster file system usage. No, all are not applicable. I think it will take some time to fetch here. And total GB, you see, 4 GB of this is a not count. Okay, I mean not memory. Used is total 4. It will take some time to getting the actual data here. Some data are there and some will onboarding. Container CPUs usage. These are the container CPU usage. Okay, these are for our deployment containers. Different containers we deployed. That's for Kubernetes cases. We also deploying containers. Actually, this Grafana is running inside a pod. I mean a container. Then container memory usage, container network usage, CPU usage, system CPU usage, not data available. Memory also same. Or process CPU utilization. Yeah, this way we onboarding our applications. Then I'm going to add one more dashboard for a different. That 461473111. Could not find a valid graph ID. I think the graph ID is yes. There's a space, that's why it's made. Yes, this ID, I mean, graph ID will show some cluster details. You see how many deployments are in our clusters. Okay, how many deployment updates are happened there. Number of nodes, there is 2 nodes, and number of pods running in our cluster 13. Okay, then content running 70. And these are the deployments. I mean, our deployments happen in a Kubernetes cluster. All deployments are for our, Grafana. We didn't install any application as of now. So we can go here and deploy a sample application, like for which one? Kubernetes. Yeah, we can directly install an Nginx deployment. Okay. This is the simplest way to deploy a application. You see, the deployment is done. That name is Nginx. So go to our dashboard, refresh, reload. You see, Nginx is here. Got it. Anyone have any doubt?
Yeah, I have a lot of that. The
Yes. One more thing. Can you chat?
can you download this?
Your
can
voice
hear me?
is breaking actually. I can hear, but I couldn't hear all the things. If you type in chat, then I will explain.
Okay, next question.
Okay.
The fact of like you combine. Okay, can we install them one by one? I mean, Prometheus and Grafana, or do you have only one code to install both together?
Together using Helm chart. You see, we install Prometheus community Helm stack. I mean Prometheus stack. Inside stack there is a Grafana. Otherwise, we can directly, go to do the both step for Prometheus and Grafana. Using Helm, it's simplest. Inside a single YAML, yeah, Helm chart have different YAML file, right? Inside single YAML, they define these both services, Prometheus and Grafana. We didn't bother about anything. We just install the, we just talk with the Helm to install the both using the corresponding Helm chart. I mean the YAML file.
Okay, I understand that one. Now, how to configure both of them, like how to make them talk to each other, like configuration.
Means?
Do you get my question? Like Prometheus and the Grafana, how to configure both so that automatically Grafana can talk to Prometheus and vice
Yes.
versa.
Yes.
How to do that?
You mean how these tools are
How to combine, how to configure Prometheus and the Grafana so that Grafana can automatically pull the things from Prometheus. How to combine both to work together. Configuration.
yeah, this is an example where we configure, combine these two, Prometheus and Grafana. We already combined these two.
I didn't see that. That's why maybe I was lost.
Actually, I didn't get your question. We combined these tools, okay? Prometheus and Grafana. I will explain.
Somebody write on the chat.
Oh, give me a second. Can you install PG? The question is how to configure Prometheus with Grafana, right?
Yes.
Yeah. Okay. In our case, okay. In our case, we didn't bother about the configuration part, right? Configuration. Why? Because we use Helm package, right? Helm package. Helm package means what? Helm package for Prometheus. We use Helm package. We install Helm package for Prometheus. What is Helm package? Helm package is a YAML file, right?
Yes.
So inside the YAML, the configuration is there, right? The combination of Prometheus and Grafana.
That one I didn't see.
Yeah, we are not going to the YAML file actually. We know there's a YAML and our requirement is we need to set up the Prometheus and Grafana. That's our requirement. There is two ways we can deploy these things. One is we can go with create a YAML file and we mention all the things. And yeah, there is a dependencies, all things we need to mention. This is for the Prometheus, this is for Grafana, and we need to deploy the YAML file. This is first case. Then coming to production, we didn't go through for this case. I mean, this is a community-based version. I mean, open source application, and we just using, but the communities, there is a Helm package for the community, and we just copy using the Helm and install the same YAML file. Got it?
Okay.
That's why we are using
But
Helm.
yeah, do you have that file and show me that one, please? Can you show that to me in the file?
You mean the YAML file, right?
Yeah, YAML file.
The YAML files belongs to the.
Can I say something? In the Amazon, we use the curl command to get the already existing Helm package. That Helm package already had the steps for installing the containers for Grafana and Prometheus.
Yes, right.
Okay. Thank you.
Yep.
Yeah. Can you hear me now this time?
Yep. Which one?
Okay, I changed my laptop. I'm saying that Grafana and Prometheus, can you download it in a traditional way, like download and install, and then you configure?
Yes. Yeah. If you need, then I will take a section.
Yeah, because I did it like that, just to download. I saw it on the internet. You can just download, but from there, I didn't know what to do. But now you use kubectl to create everything. That
Yes.
is why I also got confused. That
Now we
I
are
don't know.
working Kubernetes. That's why and most probably we configure these tools Prometheus, Grafana for Kubernetes cluster mounted.
Okay, but now in case you want to use EC2.
Yes. Some cases. Yes, some
to-
cases or some test cases we need to configure the same in EC2 machine. Like we didn't configure, I mean, we didn't go with the Helm. We directly installed Prometheus, Grafana and onboarding. That's all.
Okay.
Yeah, if all of you need, then I will take a section. I mean, a quick section for the EC2 version. I mean, single host monitoring.
Okay. It's important. Thank you. It's very important.
Okay.
To know the other side also.
Mm-hmm. Yeah. Anyone have any doubt?
So we can deploy multiple applications.
Yes.
Okay, thank you.
Multiple application in sense of?
Like we have deployed Nginx now.
Yes.
So-
For example, we can deploy the use Angular application. Any application, it will automatically fetch in our Grafana dashboard. That's why I'm
Yeah.
first here. There's no Nginx. Now the Nginx is here, and the count is. I mean, this is 18 like that. It will add as per the content line code.
Okay, thank you.
Any other doubt? Fine, right?
Hello.
Yep.
You created this in kubectl level. Do you use the same thing in Docker level also?
Yes.
Okay. So we have two tasks, EC2 and Docker.
Yep.
Helm.
Helm.
Yes.
M. or Helm.
Hello.
Yeah, I think yeah, Helm. Yes.
Should be in the form of please password keep statement.
Can you increase?
Any other doubt?
Yeah, good.
Any other doubt?
No, sir.
What about others?
For me, my first time you are doing this, so I'm having, except you do the other way, using EC2 and Docker level to do this Prometheus and Grafana, then I can capture this. I'm not getting this now.
I mean, you confuse, huh?
Yeah. What I know is you are downloading like a new way of downloading, as you said before. But that is why I asked the question that can you download it traditional way and install
Yes.
on your laptop? I did it. I download Grafana, I download that Prometheus, but I don't know how to configure two or both of them and then integrate it with
Yeah.
any running application. So I just stopped there. So now when you are doing this, it's a different thing that I get confused. I lost.
Then I will show you how to set up in the traditional way. Okay. Everything's okay.
Okay, that will be better for us.
Sorry.
That will be good.
Okay, fine. If everything is fine, then we can wind up, right?
Can you do the EC2 one or?
Yeah, we can do it for one. That's, for example, you need to take a EC2 and deposit things, and we will get the metrics and logs related to the single EC2.
Yeah, that will be fine. I can learn from there. When I understand that basic, thank you.
Everything is fine, right?
Yeah.
Similar product that
Sir,
Sorry?
HEM.
Okay. Confusing. Yeah, then we can wind up, right?
Yes, sir.
Okay.
what are the similar observable tools that we can use apart from Prometheus?
Yeah, Prometheus is the most commonly used application, Prometheus and Grafana. And this is open source. That's why we are mostly all are using. Then
Idea is Prometheus may be supported by AWS as well. Sorry, Azure and
yes. Most of the
other
providers will
Google.
support. Yeah. And one more observability tools I include in the section, that is Datadog. So, but Datadog is paid version actually. We need to pay for the services. And why I add Datadog means, in US and not in Canada. I don't know whether Canada's organization using Datadog, but coming to US, I see several organizations and most of the organizations using Datadog there as SRE. It's all related to the SRE part. Got it. All are done, right? Everyone.
Yes.
Okay.
Okay.
Sir, can you share the recording link soon? Looks like this one. Lot of things we installed.
Yeah, I
Get
will
comfort.
write up all the things. This is the script I have. This I will share the same thing.
If you type history now, everything you type will come.
Sorry.
I was saying that if you type history, all the commands will come and we'll be using the commands before the video comes. Like if you type history and then no history, and then all the commands will come.
Okay, I will
And
share
then
it.
we Hmm. Get manifest table Prometheus. What is that?
This is for getting the manifest actually. Using the release name, we can getting the manifest. But my release name is PP version chart. Not working actually. The question is here.
Can I talk? Can you find out from -- help?
Sorry.
I'm saying that if you can check if you can use help -- help to see if you can what you are looking for.
No. I'm looking the same thing, but I'm confused.
Yeah.
Version, yeah. Version is one.
Oh. Mm.
Yeah. Then we can wind up, right? Its time is I think too late. 8:50.
Yes.
Yeah. For the coming section, we can deploy the same. I mean, traditional way. Okay. Getting a single node and deploy the same thing and configure the thing. So you will get an idea how these two things are combines maybe together and works, getting the low for us. I mean for the
Yeah.
Grafana.
Yeah.
Okay.
Yeah. That look like a basic, and then from there, then I can go to kubectl.
Yes. We got it.
Thank you.
Bye bye.
Okay, bye. Okay then.
Thank you so
Okay.